Hey guys, how's it going? Oh, I should mention, I disabled the voice activated chat for this thing, so everyone, if you want to talk, you got to push the chat. So we can try to avoid some of the craziness that we had last time. That's a good question. I don't know, actually. Because I don't have to do push to chat. Let's take a look. Yeah, it's in the settings. If you don't have it set up ahead of time, there's nothing. So you have to go into your settings and set what key you want to use for push to chat. Hey, yeah, I hear you. Yes, it works. Nope, Jeremy didn't miss anything. But you might have missed the part where we said it's got to be pushed to talk. So we're here. Welcome to Office Hours. Who's got questions? How to get them? Okay, so the question was, you can make a 1-bit adder, but we're struggling to, like, how do you pass bits from one to the other? Okay, let's go ahead and let's go ahead and do that. Let's see what we got. I'm gonna create I should call it adder.v. And I've switched over to Atom from VS Code for a little while. Not for any, like, particular reason. We're gonna move stuff around. Okay, so let me quickly spin up a full adder. So it's gonna have what? A, B, C, N, S, C out. In module. Now I don't remember the logic off the top of my head for the full adder. Maybe one of you guys can help me out. Input A, B, C, N, output S, and C out. Thanks, Mason. Let's see. Yeah. Knew it involved XOR gates. A and B, XOR. So A, XOR B, XOR CN. That's S. And assign C out equal to what? A and B, or CN and A XOR B. That seems to make sense. I guess we can go ahead and verify it there. by making a test bench. Let me navigate my PowerShell. cd /des /office. Nope, doesn't exist. Oh, I'm stupid. No first slash. Okay. Clear. Let's go ahead and make a test bench for the full adder. Just to say we did. For those of you guys who are just logging in, remember if you want to ask questions, you got to do push to chat, and that's a setting you have to set yourself. Also, right now we're about to talk about how to link our adders together. But first, I got to make a full adder, so just kind of hang out for a second. Let's do this. CNS, yeah. Man, I was hoping to cheat and get away with not having to. Why did that not work? Fine, I'll do a waveform. Okay, so it looks like our thing is messed up. So let's go ahead and take a look at what we got. So this is good. Let's make a learning opportunity. So I'd initially tried to not use a waveform. I was just gonna like print out the output. Notice I got a bunch of X's for undefined signals at a couple of places, and then decided, all right, let's just go ahead and do the waveform. The waveform business confirmed that those X's do exist. So we need to kind of take a look. The red X's mean that the signals are undefined. So there's something that's messed up. Cout was defined as 0 once and then went undefined, and then was defined here at the very end, But this just shows that we've got a bit of a mess in our adder.v. So let's take a look at what we did. So sc out A, B, C, and S. Oh, you guys probably want to see it, don't you? Don't forget, you can also watch it on YouTube, but yeah, let me go ahead and share the screen. Okay. Oh, wait, that's the wrong screen. Stop. Okay, so we've got all these signals that are undefined. Does anyone see what mistake we made? I'll give you a hint, it happened here. That caused all of our signals to be undefined, or most of our signals here to be undefined. It's not that I was supposed to assign them, right? We don't need to do assignments in the test benches, but notice that our inputs are dependent upon Cn, and we forgot to assign a value for Cn. We treated this as a half adder, basically. We only gave it 2 bits of input as opposed to the 3 bits that it needs. So I actually need to get rid of that and modify this to be A, B, and Cn, and 0, 0, 0. 3, 4, 5, 6, 7, 2. So typically, if you start to see this red in your waveform, that means you either forgot to define an input in your test bench or you missed a connection somewhere in the module. Okay, so 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and I guess we need one more line for 1, 1, 1. Now we should be able, let's go to GTK wave. Sometimes it just needs to die. There we go. Oop. Now here's a crazy error. Full adder TB14, extra digits given for sized binary constant. So I upgraded this to 3-bit vector, and I changed these to 3 bits, but I need to specify that we're actually working with 3 bits. I didn't update those guys to be 2 bits. So let's try again. That looks better. And there we go. So 0 plus 0 plus 0 is 0, 0, 1, 0, 1, 1, 0. And that is, if I remember correctly, the correct truth table for a 3-bit or full adder. So before we move on to the actual real thing that we wanted to talk about, are there any questions about this module or its test bench? So Jerome asks, what S in the parentheses? I'm not sure what you mean. What's in the parentheses? In what parentheses? Lines 14 to 21. Thin line. You're talking about this stuff right here? Yeah. Okay. So this is, it's just a display thing, or it's just the display, so we can display a message out to the terminal, to the console. Just it's a pretty simple print statement. We've got our string here, and then these modulo Ds are the placeholders for the variables we want to display. So the first one, and after the end of the string, you do comma, then the thing you want to display, and it goes in order, right? So since this was the first modulo D, it takes from the first parameter there. The second one takes from the second one, and so on and so forth. And so, yeah, that gets that output. That's okay. This is still a good question. I'm sure there are other people that wanted to know. Any other questions about the 1-bit full adder or its test bench? And don't forget, if you've come in a little bit late, you are now set on push to talk instead of voice activated. So if you'd like to ask a question, you need to make sure you push to talk. Zach, I see, it looks like you are trying to say something, but I can't hear you. Okay, well, if there's no questions about that, let's go on to the thing we wanted to talk about. So let's go ahead and do the actual adder. So module adder, A, B, C, N, S, C out, and module. Now let's go ahead and make, it wouldn't be sporting to just do the assignment directly, so let's go ahead and make a 4-bit adder. But as I'm sure you know, there's nothing fundamentally different about the 4-bit or the 8-bit, it's just more bits. So anything that happens here applies to that 8-bit adder. So let's see, we need to create inputs. So our inputs are now 4 bits, so we need to have 3 to 0, A and B. Remember that Cin is just 1 bit. And then we have our output. That is also 4 bits for S. And our, so that's S. And a 1-bit output for C out. So that's how we set up the input parameters. Now what we want to do is we need a wire to connect. This is the answer to your question, is we need a wire to connect the outputs from one adder to the outputs, or excuse me, to the inputs of the other adder. So let me instantiate the adders part of the way, and then we'll go back. So full adder, we'll call this U0. It takes as its A, our A sub 0. It takes as its B, our B sub 0. It takes as its Cn, this is the important part, Cn. Since it's the first one, it takes from the input directly. Its S is going to be attached to S0. And its C out, we're going to leave blank for just a second. And then we're going to repeat that for the other 4 bits. This is the part where if you're doing an 8-bit adder, you just do this 8 times instead of 4 times. Whoa, not that. All right, so we'll call that U1, U2, U3. It takes from A, 1, 2, and 3. Remember, we're just lining up all of the bits. B1, B2, B3, and S1, S2, and S3. We also need to get rid of the Cins for all of the adders that aren't the first one. And the last one, its C out, is actually connected to our output C out. So the last thing we need is wires to connect this C out to this C in. And that C out to that C in. And that C out to that C in. So we're going to need 3 wires. So I'm just going to do wire 0, wire 1, and wire 2. You could do it by having a 3-bit wire, but, you know, we've done that before. Who wants to do that again? So the C out of the first adder goes to W0, wire 0. And that wire connects to the C in of adder 1. So that W0. And its C out connects wire 1, connects that C out to the C in of the next one, wire 1. And that C out, the C out of U2 connects with wire 2, and wire 2 connects it to C in of full adder 3. And that's it. We are done. Any questions about the module before we go to make the test bench? Remember that you got to set up your push to talk if you want to ask a question now. Okay, so I guess let's go ahead and make a test bench, right? So I'm going to create a new file. We'll call this adder underscore tb dot v. You know what? I want to be lazy. Let's just take those two lines. I really hate typing it out every time. Module adder underscore tb end module. Now here we've got some room to get weird if we want to, or not if we don't want to. Remember, we've got register our inputs A and B, which we're going to go ahead and assign to 0. A equals 0. B equals 0. Reg Cn, which we'll also assign to 0, just to sort of not have any of that undefined business. And then wire 3 to 0. S and wire cout. Now our adder UUT A, B, Cn, S, cout. Initial begin and end. So now here's where we have some flexibility. Kind of like with the multiplexer, you don't need to sort of exhaustively test everything. You could, right? We could use for loops to run through everything, but I mean, honestly, it's good enough just to say, let's set, you know, A equal to, I don't know, the 4-bit binary number 7, delay for 20. And let's set B equal to the 4-bit binary number 3, delay for 20. And then let's see what the output is. Display A equals what are you talking about? Oh, you're right. Good catch. G and D. Actually, let's do it this way. Let's do modulo D plus modulo D equals modulo D. And we'll say A, B, and S. I'm going to put that down here. And we go and run it. Clear. iVerilog option O. Adder.vvp. Adder underscore tb dot v. Nothing went wrong. VVP. Adder.vvp. And we see that 7 plus 3 equals 10. So addition is working. We could do, you know, 2 and 9. And run it again. 2 plus 9 is equal to 11, right? So we see that it's adding. This is all that we need to do. Yeah, we could, maybe we'll do it, you know, if we've got some time and if anyone's interested, we might do an exhaustive test. But this is really all you need to do. Just do this a couple times so that you're comfortable that your adder is doing it correctly. I guess we ought to make sure that Cn and cout are working. So let's go ahead and set Cn equal to 1. Delay for 20. Let's go ahead and add a thing here. And, you know, I've never done this before. We're going to try this. So we need to get 15. So we'll go, what, 5, 9, and 1 should give us 15, right? Let's see if that works. So I said A is equal to 5, B is equal to 9, which would be 14 on its own. Cn is equal to 1. So we should get 15. This is the tests that we need to do to make sure cout is getting something correctly. I'm going to try this first, even though I've never done this before. I'm going to say equal to modulo D to get a decimal number, and I'm going to wrap cout in S in a vector so that maybe it'll, you know, do the thing. So let's take a look. And it didn't work. Oh, actually, it did kind of work. Let's do, I just screwed it up. AB plus CN, and that vector. Yeah, look at that. 15 plus 9 plus 1 is equal to 15. Or excuse me, 5 plus 9 plus 1 is equal to 15. So in that case, we've tested that the C in and the C out are doing what they're supposed to. They have the correct effect on the circuit. So for you working on the assignment, like that's totally sufficient. You don't need to go ahead and create for loops or anything like that. So man, that is all there is to it for developing this adder. Like we said, if you want to make an 8-bit adder, just make 4 more of these. The thing that people are going to screw up are not updating these guys to be 8 bits. And also, I've seen a lot of people making C in and C out be multiple bits. Don't do that. C in and C out are always 1 bit, no matter how many bits everything else is. So that's that. What questions do you guys have? Don't forget you got to push to talk. What do you mean by the inputs and outputs always equaling the total? Yeah. Let me say, okay, so you're saying let's roll back. So what are these same number of bits? Like what was 8 in your scenario here? If it was 8 bits for output, okay, so that's a good question. So the question was for everyone on YouTube, is it always like the same number of bits? If it's 8 bits of input and 8 bits of output, is it always, or if 8 bits of input, is it always 8 bits of output? Yeah. So remember when we add, it's always going to be 1 more bit than we started with. So a 4-bit adder is going to have a 4-bit sum and 1 bit for carry out. An 8-bit adder is going to have 8 bits of sum and 1 bit of carry out. Even with, so 9 bits total to do the addition for 8 bits of input. Did that answer your question? All right, what else? Let's see here. James asks, why are C in and C out always 1 bit? Because they just are, right? So that's the 1 bit carry in to the adder and 1 bit carry out. Yeah, they never need to be more than 1 bit. If I want to make an 8-bit subtractor, is it any different? Yes, but structurally, no. And in fact, there's a way to do it that really doesn't change anything at all here in this circuit. But if I showed you that now, we wouldn't have anything to talk about next time. Yeah, there's a very, very simple tweak you can make to this to make it an adder subtractor. And some of you, if you've watched the video on adder subtractors, probably already know what it is. So, what else? Do we need to go negative for a subtractor? What do you mean by go negative for a subtractor? Oh, like 50, like minus 100. Yes, remember, since the subtractor is using 2's complement values, or the 2's complement scheme, the result will be a 2's complement number. So if it's negative, it will be the negative 2's complement result. So yes, the adder subtractor can get negative outputs. What else? I had a lot of port errors on the full adder calls. Talk about these guys. So you just got to make sure that everything's, just make sure everything's lining up properly. Yeah, I mean, it's probably I mean, to be totally honest, you're probably just. I mean, we did this last time, right? I made this mistake. You're probably just like missing a parenthesis somewhere, or like a square bracket. It's usually something dumb like that. You can take a screenshot and post it in the chat. And we can all find it for you. Can you show me a screenshot of the error? Yes, for 8 bits, you're going to need more wires to connect the other guys. Ooh, I really didn't like that. Invalid module instantiation. What you got? Yeah. Yep, that's it. Good catch, Clay. No. She was talking about after the Bs, after your B, like port connection. Yeah. What other questions we got? That'll do it. Good to hear. Okay, if there are no other questions, I'm going to go ahead and kill the stream then, and we'll sort of officially end this session. But I'll hang out for another 15 minutes or so to answer any more questions that come up. Does anyone have a question before we officially call it over? Thanks, Jerome. You too, man. Okay, so if there's no other questions, thank you much for coming to this edition of Office Hours Live, my new TV show. And I'm gonna go and kill the stream, and like I said, I'll hang out for another 15 minutes here on the Discord if anyone wants to ask any more questions. So, thank you so much, guys. Thanks, Chloe. You too.